Welcome everyone on today's Metal3 Community meeting. My name is Adam Rosman. I will be your host today. Today is 14th of September 2022, and please remember that the meeting is recorded. And we would start with introductions, but I think there are no new members who would like to introduce themselves. So let's start.
Sorry, Adam, you're really quiet.
Oh.
We can hear you, but a bit of on the edge. You maybe increase your volume.
One second. Let me quickly check.
That was fine for me. I don't know.
Is it better now?
Yes.
Yes.
Okay. So then I will just start from the beginning. So welcome everyone on today's Metal3 Community meeting. My name is Adam Rosman. I will be your host today. Today is 14th of September 2022, and please note that the meeting is being recorded. We don't have new participants in the meeting, so we can skip the introductions. And the first and the reminder that please check out our new release candidate and feel free to test it. And the first agenda point is from Dimitri, related to the fate of the ironic agent image.
Thank you. Yeah, it's just to highlight something I posted to the mailing list a few days ago. So we in Red Hat have this containerized ironic agent, which is different from what upstream Metal3 is using. So as a recap, upstream Metal3 is using the image provided by RDO, which is based on CentOS Stream 9, I assume at this point, and is built using some pretty dirty magic and stuff. In OpenShift, we're using an image based on CoreOS, where ironic agent is launched as a container. There are pros and cons. I can go into them if you want to, but the thing is, we created an upstream counterpart of our ironic agent container, which is metal3-io/ironic agent image. And unfortunately, I don't think our team has a lot of cycles to maintain that. Which is, we can do that, but we also want to evaluate interest of anybody upstream to participate in that and maybe use this image. And by the way, don't pay too much attention to this README. It was written for, very, very long ago. So let's put it this way. It's not an instruction how to use it with Metal3, which is another thing that we don't have. So given that our team is pretty small nowadays, I do not like us to maintain this if there's no active upstream interest in doing that. So the question is if anybody upstream wants to have a different ironic Python agent image maintained together here in Metal3 organization, or we can remove these bits from upstream, and whoever is interested can actually use OpenShift images for good. So, opinions?
There would be something to be said for building the CentOS image in such a way that it just runs this agent image in Podman or whatever. And then if somebody wanted to do another, something not based on CentOS, then they could use that same image. That said, I think the build process comes from upstream ironic, right? It comes from RDO. It's not like something we can really change. So I don't know that there's.
Yeah, so what we use upstream is RDO images that are built per ironic upstream process, which does not involve containers and will probably become more cumbersome if we start using containers there. And it's going to be a tough sell because, for example, in OpenShift, we had a few regressions because of containers. Yeah, I don't think we are going to change it upstream in ironic.
Yeah, and it probably doesn't make sense to do our own thing in Metal Cubed, like to build a different process for building a CentOS image than from what Ironic uses upstream. So I think even though that arguably would be a better design, I don't think doesn't sound like it's going to happen.
I think we are not really. I mean, we wouldn't use this in our current dev for CapM3. That's for sure. We are using the upstream one, what Dimitri just mentioned, and we also build it in the CI. Like we build one CentOS image in the CI, in the Metal3 CI, periodically, just to test a few things. But that's also based on the OpenDev Ironic, the IPA builder, and we build this ROM image, or how you say it. So I don't think from our part there is any requirement for this. I haven't heard about anything, and we are not using it in the dev.
The only benefit that this can actually give is just to give an example of how to build an image which is not conventionally built on CentOS but on some other OS. But given that the README has also been outdated, I also don't see any point of actually maintaining it as a repo. Perhaps somewhere in as a doc or demo, this can be actually added. But I think we can discontinue the repo.
Yeah, I also think the same.
Okay, I'll leave a bit more time for people to answer on the mailing list if someone is not on this meeting, and then I'll proceed with archiving repos and updating readmes to point OpenShift and removing parts of Ironic image that are specific to this work, which we don't even use in OpenShift, these parts.
Okay. Then I think among today's participants there are surely no one else, because only Red Hat and EST members are present at the moment. Yeah, so I think only the wider community, maybe they are interested, but I'm not sure. Okay, we can continue then. Thank you for bringing this up. And if there are no other questions related to this, then let's go to the next agenda point. It's related to the BMO release cycle. So lately, a technical release process was introduced into the BMO that you all know, and Feruz, before he left the project, released a version of BMO. And now some time passed, and we actually have a situation that we have this ability to release these, but we don't really have at the moment a comprehensive release guide, not a technical one to how to release it, but what and when to release, and from which branch, because the original release was also included a release branch, and now as we actually way ahead of this 0.1.0 branch, we would actually need for a few reasons that I have mentioned here. For example, this PR would require more releases, and I think patch releases would be nice, but we started to discuss this, that actually it is not decided yet that how do we do patch releases, and I just listed those things here, and what is our opinion, or like a guide about doing releases. So let's discuss that. How would we want to do these releases? Do we want to release the patches always from these release branches? So so basically that we cannot release patch versions from the main branch. We can only release patch versions from the release branches, and then we develop anyways. Like we continue development always on the main, but we release the patches from the release branches. Or do we do a rolling release style, that basically we just go forward and do 0.2 for some time, or some other option. Basically, we are at the beginning, so we can do whatever we want, but that will stick with us.
As a data point about branches, so we maintain quite a few branches in Ironic, and that's not a zero work. So they're not zero cost, let's put it this way. Maintaining branches take effort, especially when CI starts differing between the main branch and the maintenance branch. So I don't know if we really need to maintain branches so much at this point. Is it something somebody actually wants to have? I know we have branches in OpenShift, but we cherry pick stuff from main branch. But just as a word of caution, it won't come for free, especially as the number of branches increase. So at least we need some clear policy on for how long each branch is maintained, and what maintained means, and which sort of things are backported. If you don't want to do this work, or if you don't see a clear need for this work, we can probably start with rolling release, where we just release stuff from main as we seem fit, and wait for somebody to actually ask for a different approach.
Yeah, I agree. Yeah, I agree. The problem is, as Dimitri, you mentioned that it would actually require a lot of tasks to have at least a lot of jobs for the CI to actually do a test. So, and then if we now, for example, the problem that we currently have, we are already 30 commits ahead in the main branch from the release 1.1. Now, if we want to do a patch release, we have to either pick and choose the commits that we need to cherry pick for that branch, or then we do a really new branching and do a release from that. And that also requires new jobs to actually test against both. So if everyone agrees, I think the best would be to probably stop continuing anything on the release branch that we created, and then keep on releasing from main branch. But then in future, when we have a new, let's say, API bump, then we can think about if we can have separate branches for different APIs. That would make sense. At least that's what we do in CAPM3.
Yeah, I think once we get to 1.0, then it makes sense to have release branches. But yeah, for now, let's not.
And just to clear up the repo, should we keep the current this single release branch? Because then in the future, as you mentioned, we wouldn't do it, and we would just release from the main, and then basically we would just probably tag them. So we tag them, we release them, and nothing else. But at that point, I think having the release 0.1 is not really useful anymore, because there we would just have a main and a 0.1, and we might be at 0.9 release version, and it might confuse people. I'm not sure. I mean, if you think it doesn't matter, it can stay there, then we can just leave that branch there.
I didn't get your point. So you mean that we do now a release 1.0.1.1, but from main branch, and we don't touch the release branch anymore? Is it what you said?
Yeah. This was just a rolling release. What I asked now is right now, like if we go with the way you just discussed with Dimitri, that we do it as in a rolling release way and we don't create branches, then let's say a year from now we will be at release, I don't know, 0.5, but we will have like only these branches basically, and we will have this release 0.1 branch just living in our repo, but we are actually not using release branches.
I'm rather in favor of deleting this branch if we decide to go the way we just discussed, so that there is no confusion.
Yeah, it's fine. Maybe I also think that this is cleaner if it's not there and we just tag the commits and release. Should we actually then start a discussion in the wider community about it, or is it enough?
I have a plan to actually write at least some more docs about this. I will open a WIP PR, and I would appreciate comments there. That how do we decide in future? I mean, I think at least this point is clear that we are gonna do rolling releases from the main branch. So, but then for future, what will actually let's say initiate a minor release, or when do we do a major release? Those things, I think it's better that we start documenting those things now that we have a release process.
Yeah.
And one point here, we already have the releasing.md in the BMO, and there, as far as I know, we already described that we create a release branch, and then do a release from that. So if you decide only doing a release from main, then those nodes should be updated accordingly. Yeah, this one.
Yeah, that's true. But yeah, it's just a question of updating. And yeah, this still, as we discussed before, it still does not count as an actual release guide. And Kashif, you mentioned that you would do some additional things related to this. So are you planning to put a actual release guide into this repo?
I am just planning to put something similar that we have in the CAPI or CAPM3 workflow, and then we can review and invest, and then probably think to see if what we can adapt from there and what is not good for BMO.
Mm-hmm. Okay. Well, yeah. From my part, it's fine, and I think there are no objections. I just note here that we have some sorry. We have some comments here. Why is it so bad?
I can take care of it. You can continue, Adam.
Wait. Just a second. I will continue. Okay, you can continue. I won't mess around with this. Okay. Then the next agenda point is from Dimitri. Review requests.
Thank you. Yeah, just a couple of things that have been sitting there for a while. Oh, this is an updated pull request from another person who started it several months ago and got review feedback. And I decided to revive it here. And then I got review feedback from Zane about some changes that I did add, but I would love somebody who actually understands Kubernetes well to review that and see if these changes are correct. And basically, it's about being able to share the same BMC secret for several bare metal hosts. But there's some logic to update existing secrets, which may or may not be correct. It's pretty hard to test. And the second one is probably a bit more trivial, but again, probably requires some careful reviewing. I just noticed by looking at our logs that we always consider, even if there is no RAID and simple root device hints, we always consider them updated because we compare, I don't remember what exactly, I'm comparing new to an empty map or something, and they never compare. So we always think there is an update. Then it does not end up in a request to ironic, but we do end up entering the code path, which involves updating root device hints or bias settings, RAID settings, sorry. If somebody could take a look at Blossom.
Yeah, those ones are, all the RAID stuff is like fraught with, but you might want to talk to the folks from Fujitsu, I think was who originally wrote that.
No, so there is some yeah, I know what you're talking about. So there's some difference in behavior between empty volumes and new volumes,
Yes.
but not between empty RAID or not populated RAID. So there's some subtlety there. If you look at the code, I think you understand what it's about. So it does not, what I'm doing here does not cause a change in how RAID is built. It's more like we don't start taking an unnecessary code path to figure that out.
Yeah, I get what you're saying, that there's some distinction between like nil and an empty list that we don't want to disturb. And I'm not going to try to explain what it is because I'll probably get the details wrong and make everyone more confused. But yeah, we could check in with those folks who wrote it, and they actually have the hardware available to test, I think. So
yeah, it's a good idea. So the difference is if there's no RAID at all, we don't touch it. If they're empty volumes, like empty slice, we remove existing RAID. Just for your reference.
yeah, that sounds familiar.
Okay, is there anyone who would like to comment on this? But I think I'm not sure that there are anyone else who would be familiar with these. Okay, if not, then thank you for bringing this up, and let's continue. And it is from Furkat, and this will be a bit bigger one. This was the one that was announced ahead of the meeting related to the EPAM contract support. And I don't even know how to show
Adam,
it.
is it so that you have skipped one? There was another review request from Furkat.
Yeah, yeah, that's fine. Yeah, please, yeah, if you could
Okay.
discuss this one for
Sorry.
a sec. No problem. Yeah, so this is also related to the versioning. So after we did the release, we tagged API and hardware utils, if I'm not mistaken, the submodels that we have in the repo. And then there are people who wanted to import those, and then they are facing some problems since they are not updated in the Go models. So I would really appreciate if someone could take a look. There's a PR open that updates those submodels before we do a release, next patch release. It should be this one, yeah. It's pretty simple. If you open a files change for a sec, yeah. We already have this utils and an API tagged and available.
Yeah, thanks. Yeah, I think it's a question of review. So if anyone has time, please check it. Thank you, Furkat. Okay, now we can actually continue with the EPAM. Let me close everything else. And then this is the EPAM contract discussion. It's in EPAM 3, and then I think I will. I cannot really show this next to each other, but then let's go through the basic points, and I will give the stage to you, Furkat. So we will discuss how to handle the backward compatibility policy and concerns regarding the upgrade related scenarios and how do we ensure the resiliency. And then please, Furkat.
Thanks, Adam. Yeah, you're already on the issue. So it's about the support for KPI PAM in the Metal3. First of all, thanks, Jakob, for driving this. It's a really great work that we want to see in Metal3. And I was seeing a couple of PRs from you, and we'll try our best to take them, review them, and help. So you had some questions regarding the IP allocation. Let's start with that ones first, most probably. If you go with the map, there was a question about the. So we were discussing about the IP allocation logic change, right? And then what would be the backwards compatibility in Metal3? Yeah. From my point of view, I think this should go to if we introduce a new logic for the IP allocation, then it should be in the minor release, since it's a breaking change, I would say. But I would like to hear others' opinion as well. What do you think about it? We do maintain the stable branches in KPM3, and the main is for development. All the breaking changes and all will be happening there, and we have also stable branches that we mostly accept the either bug fixes or critical security issues like patches. So any other comments on the
maybe a little summary, because probably not everyone has read this issue.
Sure. Yeah.
So what I want to change is right now in the network configuration of machines or Metal3 machine or Metal3 machines, you can reference IP address pools at different locations. It's been that way for the current Metal3 IP address manager, and it will be at least similar with the IPAM proposal. It's also actually unrelated to IPAM proposal support. I just noticed it during or while I was working on the implementation. So right now, you can reference an IP pool from the logical places, which is network data networks, as you can see on screen, or metadata IP addresses from pool, which then leads to an IP address getting allocated and written to those locations or inserted at those locations in the generated cloud init. But if you reference it from other locations, for example, from network data networks IPv4 DHCP, as an, I think in this case, you can reference it as a gateway or something, or you can also reference it to get DNS servers from it. Then it will also allocate an IP address from the pool, because that's how the code works right now. But the IP address will actually never be used. It will only use it to retrieve the gateway from the pool. Now, in my opinion, that doesn't make any sense, because if you don't have an IP address from a pool, you also don't need the gateway usually. So it probably doesn't affect anyone if we change that. So I would like to change it to only allocate addresses from pools if they are actually used. So if it's basically a reference from either metadata IP address or from network data networks, they are either IPv4 or IPv6. And if it's referenced from anywhere else, or well, only if it's referenced from those 2 or 3 locations, it will actually allocate an IP address. And the other references from other locations will only work if it's also referenced from one of those. So changing this technically, if someone is currently using it in a weird way, or at least in my opinion, it's a weird way, but it could be a valid use case for someone. If someone is, for example, using it only to get a gateway, but not to allocate an IP address and actually use it on the server, that would break. That use case would break. There's a workaround, which is just adding it to the metadata and then not using it in the cloud init script or in the cloud init config. But still, it would be, in that sense, a breaking change, even though the impact is probably pretty low, because probably nobody is using it that way. And most people that reference it, for example, for the gateway, will also use it or also reference it for an IP address, because you need an IP address to even reach the gateway anyways, at least in most cases. And if, yeah, that's pretty much it. And with the current IP address manager, unless there is some modified version that fetches the information from somewhere else, you could also just add the gateway manually directly to the template instead of fetching it from a pool or something like that. So the question now is, do we allow such, well, technically breaking changes? And is it fine to have them in minor versions? For CAPI, for example, I don't think they would allow it, or at least they would be very, very careful with stuff like that, changing any behavior that basically breaks existing functionality, unless it's like a confirmed bug and behavior that really shouldn't be that way. I mean, we could classify this one as a bug as well, that it allocates networks if they or allocates IP addresses if the IP address isn't used. Yeah, but that's the question, pretty much. Or it's a little bit hard to summarize because it's a little bit complicated if you're not deep in the network configuration part of Metal3 machines, or the data template rather. But
if I may jump in here, I think it's a good idea to do such a change like this, and the timing is really the best we could hope for now because of this change to the CAPI contract and the difference that because the IPAM contract from CAPI will not be exactly one-to-one what we had until now. That would be the perfect time to completely switch the new model and drop the support for this kind of scenarios. But then comes the question of how do we actually handle this upgrade and like the change to this new model. It looks a bit complicated because we're gonna have to have a transition period where like both objects will coexist on the cluster, like the new and the old, and like doing the transition without having like having the certainty that we are not double allocating or well, I mean allocating two different IP addresses, or like freeing IP addresses that are actually still in use on another side, or things like this is going to be probably a bit tricky. So I wanted to hear a bit like what's your view on like this upgrade process and how to perform the transition in a smooth way when we're going to introduce the new contract. So is there going to be a time period where both would coexist? Like, and how long? Like, are we talking a couple of releases, or like, is it supposed to be a one-time change, meaning that like we introduce the new contracts, we do the transition from the old to the new one, and we immediately remove the old IP manager, so that anything afterwards with the new CAPI version and the new CAPI version will be using the new contract? Or like, basically, I want to understand a bit like how you're seeing this
so
transition.
there is no problem with supporting both. The main thing, so the main reason I want to so this behavior change also doesn't really impact the old IP address manager. It still works if you use it in a, in quotation marks, sensible way to actually allocate IP addresses and then use them on the server. It would still work the same way. All of the changes I'm doing right now are fully backwards compatible. It's just adding a new field that allows you to reference pools. And with the new field, you can even reference IP address manager pools, and it will then use the old implementation to fetch IP addresses from the Metal3 IP address manager. And only if you reference different pools, it's basically switching based on group version, based on group and kind. And if you use something different that's not the IP address manager from the Metal3 project, then it will use the CAPI IPAM contract instead. And create CAPI resources instead of IP address manager resources. I just want to.
How will you like perform the switch from one to the other? Like, let's say you have a deployed cluster with like, I don't know, like X machines that are deployed, all of them using having multiple current Metal3 IP claims and like referring to many like Metal3 IP pools. How will you switch that to the new CAPI contract based?
Yeah. So if you scroll down a bit, I've written some rough steps. So my idea is, I haven't confirmed this or tested this, but from a theoretic point of view, it should work. So if you basically import the existing claims and IP addresses to a CAPI compatible provider. For example, I've worked on a in-cluster provider that then basically works the same as the current IP address manager by just having a pool and IP addresses and claims in cluster, or using the CAPI claim and IP address resources to manage IP addresses without talking to any external system. So if you just basically copy paste the IP address manager claims and IPs to the and convert them to CAPI resources for that in-cluster provider and create a pool for that in-cluster provider, then you basically have the same current data as you have with the IP address manager. And then you would need to create a new template and a new data template, and that would need to reference the new pool. And then you can modify the machine deployment that's missing in the steps here, but modify the machine deployment to use the new template. And that would then allocate IP addresses from the new pool. And then you would probably need to manually delete the claims, the old claims again. So if the pool is small, that probably requires a lot of manual interaction. If the pool is big enough, you can, if you have twice as many IPs in the pool as you need, you can just create the new machines, and then after it's done, after you're done creating the new machines, you can delete the old IP address claims that you imported before, and then after a node role, the switch should be done. That should work, in my opinion. Not too sure. If it doesn't yet, you can probably make it work by some modifications to the in-cluster provider.
I see some corner cases with that approach, where we are like the fact that we have the two pools that are concurrently existing, the old version and the new version, could lead us in situations where we get double allocations, because like one IP address being allocated to two different machines is what I mean. Because there could be like if the machine deployment, the old one, is referring to the old Metal3 machine template, and we create a new one, that new Metal3 machine template we change the reference in the machine deployment, we still have the machine set, the old one, referring to the old pool, and that one in some cases might have node rollout still, meaning that it's not only the number of replicas is not only going to go down, it might in some cases go up. In some it's very corner cases when doing the upgrade, but it can happen in the CAPI flow. And in that case, it would request an IP address from the old pool that will not be registered in the new one. Right. So like if there's a new node joining with the new pool, then it could get the same IP address if it's sequential, for example.
Yes, that's true. That's a corner case. That's probably very hard to take care of unless either I'm not sure how what a good way of handling this would be. So in theory, what you could do would be to build like a proxy mode into IP address manager that basically creates a pool that could also do it automatically then if you enable the proxy mode. So it basically, for all its existing pools, it creates matching pools in IP address in the new one, in the in-cluster IP address. In the in-cluster IPAM provider, that's the correct name. And then whenever you request an IP address from the old one, it basically proxies the request to the new one, creates a claim there, and waits for an IP address to be allocated, and then creates a matching IP address object for the with the IP address manager resources. That would require a little bit of work though. So, but that would be one option, and then it would be absolutely, or not absolutely, that's maybe a little bit of an overstatement, but that it should be a pretty good coverage also of the edge cases, because if in case the old replica set goes up again and it requests an IP address, it would essentially request it from the new provider, but through the old API. That would be something that could work. Exactly. Maybe even with annotations to basically mark old pools for conversion, and then IP address manager could even take care of creating the new resources and basically migrating the existing data over to the new provider. And then once it's done with the migration, it could switch to proxy mode and just basically redirect or replicate requests to the new provider and then replicate the answer back. That could be a viable solution.
Yeah, I think it would be key to have here a mechanism that whatever the version the claim is coming on, the JVK basically, whatever the JVK you're getting your claim with, it under the hood maintains the source of truth for your pool in a single version, even if it has to duplicate that information into like for example, the old version to make it acceptable by the old pools, basically. So, like, what I mean is, yeah, indeed, that whenever you would get a Metal3 IP claim, the first thing it would do is allocate a new type IP address, but then create an equivalent as a Metal3 IP address. But considering always that what's valid is the new type, right? That the old type is just there to provide a convenience and an equivalent of what we currently have on the new pool. But I definitely think that we won't be able to go around putting something like this in place, because otherwise it would mean that we need to at once change all references to in all objects existing Metal3 machine templates, like everywhere where we're referencing the Metal3 IP pool, to change that to reference the new type of IP pool that is following the CAPI contract. And doing all that at once could have some kind of like breaking backwards compatibility issues.
I mean,
because we would basically not allow the coexistence of the two at the same time if we were doing it this way.
I would, but you wouldn't be able to roll back, and you wouldn't be able to handle corner cases where. So this is like only covering a working migration where it goes with a regular rolling upgrade with no issues, that just removes one node from the old or adds a new node to the new machine set, removes one from the old one, just goes through like this. And then when the migration is done, no old nodes are present anymore, and nothing is referencing the old IPAM provider anymore. And then this one would work, but in case you run into issues, that would probably be a hassle. Also, you need to manually clean up the new pool and remove the old IP addresses that you imported. So actually building something into IP address manager might be a better solution, and also make it more convenient.
Yeah, this manual cleaning, I think we're going to have a problem. It might not be acceptable because of the allocations capability. We are able right now, and it's a feature we want to keep. We're able to pre-allocate the IP addresses, and Forecast is working on this change so that it would be like BMH based. So basically we are saying that this node is going to get this IP address, right? If the transition forces the new node to have a different IP address than what is expected in what you put in the pre-allocation, then we're going to have a problem there.
What's pre-allocations? I'm not aware.
So in the Metal3 IP pool, you can define a map of claim names and addresses that will be given to those claims.
Okay.
So as long as the claim name is predictable, then you can have a predictable or static IP address allocation, basically. That's what it boils down to. So it allows you to define, for example, saying okay, I have 3 nodes. The first node will have IP.11, second will have .12, and third will have .13, so that it's set as like this. And during the upgrade, meaning that the node goes away and comes back with the new version, it gets again the same IP address. So that's the logic behind those pre-allocations.
Okay.
And this mechanism and the way that because it's in use right now, and it's something needed, that will prevent us from just saying, okay, we take the Metal3 IP addresses, we translate them into the new provider, and then we don't touch it anymore until everything has migrated to new addresses, and then we get rid of them. That won't work, because then we won't be able to do this, keeping the address over the upgrade process. we'll need a better integration that ensures that whenever a node is releasing an IP address with like the Metal3 IP claim being deleted, that also releases it in the new pool so that it can be reused right away with the new IP claim following the CAPI contract.
Okay, so the new pool won't have, or at least right now, the new provider doesn't have that capability. It just picks, well, it picks the first free address in the pool. That's the behavior. So it just goes through it and finds the first one that's not used.
That won't be. I mean, it's good. It's good that it's working. It's working this way, but we, at least the use case we have for it in Ericsson, like that requires the pre-allocation feature.
Okay. Because right now it's also, so I'm just interested, so the pre-allocation, how does it work? Is it just based on order of machines, or does it actually factor in the name of the BMH or something like that? Because how do you?
Until now it was just based on the order, and that was not what we wanted. So that's why there's work ongoing to change it so that it's tied to the BMH name, right? So that like it could be just something more user-friendly, so they can like define like, okay, I know that I'm using this BMH as a control plane, as my first control plane, for example. So this BMH is going to have this IP address, and then like to get the one-to-one link between the control plane and the IP address that is used there.
Okay, but wouldn't it maybe make more sense to allow to specify to use the IP address configured on the BMH object instead of going through the IP address manager, having some lookup table there, having to basically replicate information and so on?
Not really, because the key feature there is that it's integrated with the dynamic allocation also. So you can kind of like if you have some BMHs or like any nodes that don't have the pre-allocation, it's fine. They will still get like dynamically some addresses allocated, right? So I agree that if everything was static, you could just put a label somewhere and pass it by a label, right? Like we have the feature already in the metadata. So we already have the capability to just fetch an IP address that would be as a label on one of the BMHs. But that's not what we want, right?
Okay. Yeah, I wasn't aware of this use case. So I would propose the following. So regarding migration path, I think there is a way, and the current implementation is not really blocked by it. The idea with the transparent or the proxy mode for IP address manager is probably the best option. And regarding pre-allocations, so that's something that would need to be built into the IP address manager, the in-cluster item provider. I'm sorry, the naming is killing me. As a feature, maybe I'm not sure. So right now the CAPI contract, the item contract, I mean, I've written it, but I'm not 100% sure if there's a way, but it doesn't support it right, like in a straightforward way.
Why is it not? I mean, it doesn't matter. It doesn't impact the contract by itself. It's an internal implementation detail of the in-cluster provider, right? Because we provide those IP addresses as part of the pool definition, and that pool definition is not.
That's true.
There's no contract on that.
Yeah, so if you go through the name of the claim, for example, then it would work, of course. Then the in-cluster item provider would just need to support that use case, and that's not really an issue, at least in my opinion. Then if we want to use the BMH name, maybe it gets a little bit more complicated unless you just then create claims based on the BMH name. Or
Yeah, exactly. What I meant is that the name of the claim reflects the name of the BMH.
Okay.
In the new implementation of the KPM3 IPAM. So
Yeah.
basically, the claim name is BMH name dash pool name. So it's predictable based on just on the BMH name.
Yeah. I mean, we could also do something like an annotation that allows you to select the pre-allocation IP or something like that in the worst case. So I think there is some way to add support for this again, but I wouldn't go for it in the first iteration. So maybe just open an issue to track that we need to add support for pre-allocations to the CAPI IPAM contract. And if the solution is to just build something into the in-cluster IP address manager, in-cluster IPAM provider, that's fine. And then we can add an issue there and implement support for it there at some later point. But I think it's a little bit too big for the first iteration. As I said, support for the current implementation doesn't go away. Not at all. I'm not planning on removing anything apart from, and so the only thing I wanted to like inquire about is the allocation logic and allocating addresses basically that you don't really need to allocate. Just to so, and really the only reason to do that is to simplify the code quite a bit and to make it easier to implement the CAPI IPAM, because I basically need at every location to switch between the IP address manager and CAPI, and that would just be simpler. But if we can't decide on that, then I guess I can also just.
But I was thinking regarding this, that if we could make it so that the new behavior with the IP contract, like the IPAM contract from CAPI, would not support like those gateway and DNS without having the IP address allocated somewhere, while we keep the current behavior for the Metal3 based ones until we completely drop out, like we completely stop supporting the Metal3 IP address manager, in which case the transition would, like, we wouldn't force force this like change on, like, yeah. We would have full backwards compatibility, but then they would naturally, like, whoever is using Metal3 IPAM would have anyways to switch to the in-cluster CAPI in-cluster IPAM provider. So then they would have to stop using those fields.
Okay. Yeah, I think the main reason was that it's just quite a bit more complicated to or not really, but it just felt wrong. And it's a little more work to implement because there's more logic involved to figure out which pools to allocate to. Because, for example, in some cases, so for the IP address manager, you only need the name of the pool, because there is only one kind of pool, and it has to be in the same namespace. But for the CAPI contract, you also need namespace, group and kind to reference like different types of pools, because there's supposed to be different providers. And it's a little bit more complicated then to either validate or make sure that, like, so if you're referencing one pool with one name, then you also need, so right now it's easy, you just like add all the names to a list and then allocate addresses. But in the future, I need to like differentiate between one name for one pool, but another name for another kind of pool. That is one option that could actually occur. So it's just a little bit more difficult to get a list of all the pools you want to allocate from, and then to also match the correct pool to the correct location in the configuration and so on. That it's just a little bit more complicated. And if it's less locations where you can reference a pool that makes a difference, then it's a little bit easier, I think. But anyway, I will attempt to implement it in a fully backwards compatible way. Then that's fine.
I mean, I'm not requesting that specifically, like because, like, well, we don't use the feature, but there could be other people in the wild, like other, like.
Yeah. I know that's why I wanted to ask, because there was like general, oh yeah, I guess we can remove it because it doesn't really make sense. But then the question is, what's the policy? How backwards compatible is Metal3 trying to be, and do we just, are we fine with? Because I mean, there is a workaround, as I said, just add the like request an IP address for the metadata, and they just don't use it. That works. But basically, during the upgrade, it would break existing setups if someone is using it that way and doesn't implement the workaround.
We can, like, for the removal, usually what we do is like a couple of releases with deprecation notice, like, or like a warning that something's coming up, and then do the actual change when, like, it's been like I don't know, like 3 months or something. Well, a couple of releases, let's say, so that everybody has had time to change. So I'm wondering, with the timeline that we are talking about, like now, since implementation is happening, going through this deprecation process might just be too long comparing to what we want to do if we are able to keep a full backwards compatibility.
I mean, if we want to go through the migration thing, then it needs to be fully backwards compatible for now anyway. So guess we can postpone the discussion about changing the behavior. I just implement it in a backwards compatible way. I'm probably going to get it to work, but it's just a little bit more work, which is fine. And then we can, after CAPI support is in, we can then discuss, or at some random other point isn't really related that much, we can discuss about deprecation and then finding a way to validate it properly and give proper warnings from the API server that it's going to be, that this behavior is going to be deprecated or is deprecated and is going to be removed at some point.
Yeah, but if we have the backwards compatibility anyways, then we should just say the whole IPAM is going to be deprecated, and then we don't have to.
Yeah, okay, true. That also works. Right.
We just say, like, get out of the Metal3 IPAM, and then everything is good. There's no, like, no need to put anything specific for a specific field in place. Like, we just say, like, yeah, we're stopping supporting.
Yeah, true. Good point. Yeah, then let's do it like that. Okay.
But yeah, and let me check it. I had noted a couple of things. Maybe I have another thing I would want to do. Well, if you have more time, I don't know.
I do.
Yeah, I can keep the meeting going, and if there are people who want to leave, feel free. We still have 8 people on the call.
Yeah, well, I'd definitely be up for keeping the discussion going if you don't mind.
Yep, feel free.
Okay. Then the next thing I wanted to, like, know a bit more about, let's say, is, like, for the transition itself. Like, and now, like, I'm not asking for like really like clear details or like just to see how things would be done in an idea that you have, like, of how things would go. Regarding the transition itself, like this copying of the image that you were like, the copying of the claims and the addresses that you were mentioning, the new type of pool, would that be then a separate utility, or would that be baked in the controller and done at, like, for example, like startup of the controller, or like how do you see it coming?
So if we build something into IP address manager, and if it's not too much work, then I would try to implement that into IP address manager. So that basically if you enable some flag that does conversion, then it on startup maybe, because that's probably the best. So ideally before the controllers are started, we just iterate over over all existing pools and basically convert them or copy them to the in-cluster IPAM provider resources. So essentially turning all of the IP address manager claims and IP addresses into CAPI claims and IP addresses, and creating for each IP address manager pool an in-cluster IPAM provider pool. We would make sure, of course, the in-cluster IPAM provider then needs to work in some way that it doesn't delete the stuff again, and is fine with you creating an IP address and a pool and a claim that reference each other right away. They just need to support that use case to allow conversion. And then once that's done, the IP address manager just immediately switches to proxy mode, and essentially during the conversion it probably should also link existing claims to the matching CAPI claims that it created, and then in proxy mode it just, instead of executing its own logic to allocate IP addresses, it just instead talks to the CAPI IPAM contract API, and for each claim that you creates a CAPI claim, and for each IP address the CAPI provider creates, we in turn then create an IP address manager IP address, and then that should be all we need really. And that way it's probably the easiest for users to migrate if they want to.
Yeah.
Unless they're fine with just redeploying everything, which is probably
not. Okay, so it means that we'll need something like some behavior, like the same idea as what we have with the pose for the move, for the pivoting operation, so that we can tell the in-cluster manager, don't do anything with any objects of that pool yet, because we are working on it and then transition. But getting to do that atomically will not be possible, and that's going to be very, very complicated. To switch from this mode of IPAM is recreating all the IP address and the IP claims into the new format, and switching on the in-cluster IPAM provider and disabling itself at the same time. That we're gonna have to be able to use a single flag, maybe the post flag on the.
So if we implement it correctly in the in-cluster IPAM provider, I think if you just create the IP address first, and then afterwards create the claim, and if the in-cluster provider is fine with that and doesn't reject creating an IP address before the claim is created, then it should just work, and then it should reconcile.
It's not only that, it should not, because you could have on the side an IP claim that gets created, a completely new one that is unrelated to what you're transitioning, and that one would get an IP address that you haven't yet moved, and then you have a conflict.
Well,
right. So we need to be able to completely disable the reconciliation in the in-cluster provider while we are doing the transition, and then re-enable it.
I think we should maybe discuss this again, because I don't I mean, all of this is just about migration, right? It's not that you want to run both of them for a long time in parallel. So, I mean, one use case, of course, is using the same pool of IP addresses for multiple clusters. Maybe that might be a problem then, yes. Or if you already have a new cluster that's already using the new IPAM, that's using a specific pool, and then you want to migrate other clusters into that new cluster, into that new pool, that's then probably going to be a problem. Or if you want to migrate a lot of clusters at the same time, I don't know. Sorry, if you don't want to migrate all of your clusters at the same time, that would maybe lead to problems. I mean, one option would just be to pause either the pool and implement something like that. Like in CAP, you also can pause clusters, and that basically stops all reconciliation. We could allow to pause pools, or you could just undeploy the in-cluster provider, do the conversion, and then redeploy it. So it's not running essentially during the conversion. That would also be an option.
Yeah, but that would be more on the users, up to the user to take care
True.
of that. If we have some kind of flag to say like, don't
Yeah, then-
reconcile this pool, then everything will be okay. Because if it's the IPAM itself, like the IPAM is like working across all the namespaces. So if we just upgrade the IPAM pod, and then the IPAM pod does automatically the translation into the new CAPI contract like pools, and moves all the addresses and the claims and switches into the proxy mode, then it converts, like it changes everything for all clusters at once, and then it like we can reach a kind of atomic way of doing it for all clusters.
But like it doesn't need to change it on the clusters itself. Like the clusters would still talk the old IP address manager API.
Yeah.
They wouldn't even notice really. That's at least that's my idea with the proxy mode, because so it would basically be a transparent proxy that just hands over the logic of allocating IP addresses to the in-cluster provider, but still serves the same old API that the same way it used to work before.
Yes. Yeah, exactly. So I was just talking about the copy part, because you were saying that you could not transition part of your clusters and transition the other part. But if the IPAM provider itself, like the pod, does it upon the first startup when it's upgraded to the new version, then it will do it for all clusters at once. And even if the most of the clusters are still using the old API, things will work smoothly and you will not have conflict, because like there will be a time where like all those pools are paused, the transition happens, and then we enable everything atomically, like in a single operation. And we go to proxy mode.
Yeah, but so basically, as long as you don't have any clusters using the new IPAM yet, so you essentially need to do it before migrating any of your clusters, then you're on the safe side. If you don't have conflicting pools, then you don't need to do it. Or not conflicting, but shared pools, so pools shared between clusters, then you probably also don't need to do it. So we, for example, we have one pool per cluster right now. So we could, in theory, create new clusters that use the new IPAM contract, and then at some later point migrate all the old ones without any interference.
Yeah, but if
even we don't even need to migrate because we're not using the in-cluster one, but you're using influx. But yeah.
Yeah, but I totally agree that the one case that we can't support is if you deploy a new cluster with the in-cluster like IPAM provider, and then you bring the old CAPM3 things, then there will be conflicts in the because some of the addresses will have been provided before the transition actually happens for the other. So we will have to be clear with that. But as long as we leave it up to a single component to do this transition, that would be the IPAM controller, and that is done before any new cluster would be deployed with the in-cluster provider, then we'll be safe. And
yeah, I mean, actually, it doesn't work anyway, because if you deploy clusters and they get randomly assigned IP addresses from the in-cluster provider, and then you try to migrate existing clusters, those IP addresses could already be used because they were randomly given to some other. So you need to basically do a more or less atomic migration from IP address manager to the in-cluster provider for all of the pools that you have. And you cannot create new pools for the in-cluster provider to use the same IP address ranges as the old pools from IP address manager. That just doesn't work in any case, I think. So we probably don't need to handle that specifically. You just need to do an atomic migration.
Yeah, as long as we state clearly those restrictions, and they should be fine for anybody like using the current implementations, then it's going to be okay.
Operations. I'm just writing some notes. Okay, then that's that. I think that's good. I might look into adding that functionality to the IP address manager as well. But I would also appreciate some help there because we're not really using the in-cluster part of the IP address manager. We have a hacked version that talks to info-blocks to allocate IP addresses. So our migration would be a lot easier because you can just use a to-be-written info-blocks IPAM provider, configure the same pools there, and then both the IP address manager or our version of the IP address manager and the new info-blocks provider would talk to the same info-blocks instance and just allocate addresses from there, and then you don't have any conflicts.
Yeah, of course, with external providers, and that's quite straightforward.
Yeah, and that was the main motivation of the IPAM proposal, to make it easier to integrate with external providers or to allow shared or better collaboration between infrastructure providers and external IP address management tools and all of that stuff.
I can't promise anything because Kashif is ready to drop, but he's the one to talk to, like regard to like getting help.
Then
okay.
one last.
Yeah, go on.
The one last thing might be to maybe please look at my other pull request that I have open right now. But that's also not really required for IP address for CAPI IPAM contract support. It's just an optimization of the IP address allocation. But it's a little bit, yeah, not sure if it makes, I'm pushing for a lot of stuff that's not really needed because I found it and wanted to improve it before implementing the IPAM contract, but it can technically also be postponed after implementation of the IPAM contract. It's just about, so right now, basically claims are created and then it immediately tries to find an IP address for that claim. And if that doesn't work, it posts or it just queues the machine for reconciliation or the data object for reconciliation after 30 seconds, and then looks for the IP addresses again, and then they probably are there. And this changes the behavior to create all of the claims for one data object. Then if something changed, wait for 200 milliseconds, and then fetch the claims again and look if the IP addresses are already there. Not sure if the 200 milliseconds are a good value, but just wait some time to give the IP address providers time to reconcile. And that is probably, or in my opinion, maybe a better approach and speeds up provisioning of machines. Not that it really matters with bare metal boot times of 10 minutes because of memory checks, but it might save a good 30 seconds in some cases. Because I think right now it requeues with 30-second delay basically every time. Because there's no way the IP address manager or any other IP address provider fulfills an IP address claim within like a millisecond or something.
I think it's a good idea of optimization. I would just request to change to not use sleep into a reconciliation loop and instead like send a requeue query. Because when we are using sleep, we're kind of like blocking the coroutine there.
That's true.
Yeah, I mean, I know it's a very small, like 200 milliseconds. It's like nothing, right? But if you consider, I don't know, like if we are like having a big cluster with 100 nodes and 10 IP address. But
Yeah, you're right. You're right.
it goes up quite quickly. But otherwise, like very good point. I totally agree that it would be.
I mean, we can. Then I will just remove the sleep, but still keep it this way, because it might be sufficient just to requeue, to refetch the IP claims and so on. That might be enough already for some IP addresses to be allocated. And then if it doesn't find all of them, it just requeues anyway. Maybe we can reduce it to not be 30 seconds. But okay, yeah, but that's a good point because of non-parallel reconciliation, maybe, depending on configuration.
Yes.
Mm-hmm.
But yeah, like I would put a requeue, but there's maybe no need to really, like 200 milliseconds requeue is fine. But if you want to just also return and say like reconcile again, as long as it's just not blocking within the the reconciliation loop, that's fine.
Yeah, it's probably even fine to just immediately requeue it for reconciliation because it takes long enough, probably. But yeah, that's a good point. Blocking the Go routine, and with a lot of machines, that's probably not a good idea. Yeah. Okay, thanks.
Okay.
Maybe one note on the pre-allocation. Just a heads up, it's already merged in the CapM3, the pre-allocation feature using the BMH names. And if needed, maybe later that we have to contribute to the in cluster, I'm happy to help also, since I worked on that feature.
Yeah, sounds good.
And yeah, regarding this, to clarify, like I think I might have already mentioned it to you, but I personally have an NDA, so I will not be able to. I'm not able to produce any code for open source anyway.
Ah, okay.
So that's why I'm staying a bit away.
Great. I mean, not that I blame you, but that's great policy to have an NDA that prevents you from contributing to open source by consuming it. If you are even consuming it still, but yeah. Interesting.
Mm-hmm.
Anyway, thanks for the discussion. Unfortunately, I need to leave now because of.
But we're pretty much done anyway, so I think we can just close the meeting.
Yes.
Thanks a lot. Thanks a lot
Yes.
for taking the
Thanks
time.
a lot. Thank you.
Thank you. Bye-bye.
Thank you.
Bye-bye.
See you. Bye-bye.